Hello, welcome back.
Now we are going to start doing the training. We have these errors. It won't compile now, but later we are going to create the classes backpropagation and training. So let's start in this video. Training. We define the class training. Okay. It will only implement two methods. The train neural net and the print train net result. The only purpose of this function is to print the result in its loop. I'm going to include we are going to include the training. Yes, we are going to include the training inside this here exactly. We will see later why we need to include below these methods, and why the backpropagation also is need to be included here. So we can start now. We need to define we are not going to initialize this because in the backpropagation class we are going to make a function that overloads this one, the train. The print is necessary. We can do it now. Line void training print new. Okay. So we need to add the size of the rows and size of columns. This is gonna be the of training net dot. It does not recognize train set trainnet dot. Now we know the size of each of each column in each training set. So this is the number of rows. We can deduce also the number of calls by dot train set size of double. Okay. Now we can define the vector the vector class. No. Rows. Now we have to loop through each through the each training set to see the net value. Now we are going to give the predefined value 0.0 and j less than input weight in is equal to train net dot get input layer. No, there is not a getter. Input layer dot list of neurons dot list of weight in. The error is still here, so we are going to reload the Visual Studio. This will take only a few seconds, so we can wait that. Okay. Now the error disappeared, as I said. Input weight in. This is not necessary, but help us. Net value is equal to net value plus input weight plus input weight multiplied by train net dot train set in position ij. Okay. Now we print output. with this. Okay. The estimated value is gonna be the function okay. We need to create another variable here. Now it's gonna be public. This is the more complex part of the code. We make a pointer to a list of functions, so we make an array of functions in order to make the activation function. Activation, we are going to call activation function. It has a size of 4, and we have to define it now. The way of doing that is like this. You have to okay. So now we can create the functions and put it right here in the activation function array of that is an array of functions. The first function is going to be func step. They are defined in the enumerator that we have created before. The func step is if n is greater or equal to 0, then we return 0.0, else 0.0. Okay. The function linear is very easy. It returns the number. The func log is the most common in this area. Returns 1.0, 1.0. This function is also called sigmoid. Okay, perfect. And the last function, the hypertangent, that I think that we don't need to include the math library. I don't know. We're going to see now. 10.8 of 10. Okay, this is okay. The next step is to do the derivative of each function to make the backpropagation method that is going to output the neural net depending the output of the derivative function of the linear function. We can do it now. The derivative of linear, the derivative of the linear function is really easy. It's 1. The derivative the derivative function of the sig log is this. Now we are not going to see why is this. You can check if you want or calculate. And double the derivative of the function hypertan is this 1.0 is similar to the tangent. Okay, that's all. The second linear. The step hasn't got derivative, so now we can make the array of pointers. The first is the activation function, and the second one the derivative of derivative activation function, which has a size of 3. The first one is going to be the function linear. The order is very important. It's the same that we've used in the enum. First, the linear. Second, the sigmoid. Then the hypertangent, and then the step. Okay? The linear. Then the training function siglog, then training the function hypertangent, then step. Okay, this should be correct. Oh, I forgot something. It needs to be that. This should be correct. Okay, and then the derivative of the function. The first order. First the linear, second the sigmoid, and then the hypertangent. Okay. The derivative of the linear, sigmoid. And then the hypertangent. Okay, this should be correct. So now we can make the thing that where we before. This activation function terminate dot activation function. Okay, and we close the brackets, and we are going to use the net value as the parameter. Now I'm going to explain the code. Oh, I forgot the pointer. This should be a pointer. we call to we have the activation function that has 4 different functions inside. So if we call to the activation function in position in the position of that gives us the activation function enum here, that will output 0 if it's linear, 1 signal, hypertangent 2 and 3. So this number will be between 0 and 3, and then we need the parameter that is obligatory. You must use a double. So that's all. And this simple code allows us to use a lot of functions. See out, net output, estimated output, and we make a space here. Real output set. Okay. In position Y, we make another tabular space. Dot real output set. Real output in position I, and then we print that result to know the error that we commit, that the neural network commits after finishing the learning work. So that's all. Perfect. We can start coding the backpropagation method. Very good. If you remember, we have here errors because we haven't added yet the backpropagation class, so we are going to do it now. Back propagation. We need to do something before. The backpropagation class is going to heritage from the training class and override one of its methods. So we need to make sure that the backpropagation is included before after the training. Okay. Public training. Okay. We are going to use that. We create the methods train. This is the method that overrides from training. And the special methods, the forward. There is a lot of documentation on the internet to see how it works, because it is a little bit complex. And the back propagation. Size T row. So that's all. I don't want to include in the CPP. We include the methods of the class, but we are not going to complete this now. In the next video we are going to see that. So see you in the next video, that we are going to make this thing. First we are going to see the theory of the back propagation method, and then we are going to code it to see in practice how it works. And bye.